Okay, let me briefly welcome you. We are still doing some dress rehearsals. Okay. No, it's no, do as you feel comfortable. Let me briefly introduce Meher Roy, our guest speaker today. Meher is a Bitcoin specialist. He calls himself a Bitcoin enthusiast, so we look forward to a neutral presentation on Bitcoin. I hesitated first, to be honest, to invite Meher because he has a serious affiliation with Novartis, and I was not sure whether people with serious affiliations are trustworthy when it comes to very novel things like Bitcoins, but I'm sure he will dispel our doubts very quickly. I thank Inke Nyborg for arranging this visit. And I should perhaps be honest and mention I made a poll last time. Probably was the question was very unfair. I asked students if they had, what was it, 10,000 or 20,000 Swiss francs, and they had to invest them on behalf of their children for the next 20 years. Would they buy gold or would they buy Bitcoin? And I'm sorry to say that there was a solid majority on the gold side, but it's your chance to change that today.
Okay. How do I have to hold this?
No. Just
okay, thanks so much, Professor.
So there is no break. You have 1 hour and a half.
Okay. So, hello everyone. Is my voice clear? Okay. So, thank you for agreeing to listen to me for an hour or whatever time I'm going to spend here. I am not here to talk about Bitcoins. I'm here to talk about the crypto economy. And Bitcoin is a part of the crypto economy. First, for my introduction, I am Meher. I call myself a crypto economy enthusiast, really. I have a day job in the pharmaceutical industry that pays my bills, but my passion is building this economy. And the thing I do in the evenings and weekends is I have a show on the crypto economy. We release episodes every week where we discuss the technologies that people are building with Bitcoin and other similar currencies. And these are all technology discussions, and we have around 5,000 regular viewers in Silicon Valley, in London, and perhaps after the lecture you might want to check it out. It's called Epicenter Bitcoin. Today I'm going to walk you through a couple of different items. I'm going to walk you specifically through what is a cryptocurrency, what are the special features of cryptocurrencies, and I'm also going to go through some futuristic examples and applications that this sort of technology can enable. Let me start with pointing out that there are many interesting people, many smart people in the world that somehow think that Bitcoin is special and it is going to be a big deal. So perhaps the best statement about Bitcoin or blockchain technology that I've heard is the blockchain will be to banking, law, and accountancy as the internet was to media, commerce, and advertising. So this is Joichi Ito, who is director of the MIT Media Lab, and he really believes that this is a technology that has the potential to be as big as the internet was for the previous generation. And if you have heard of the other person, which is Mark Andreessen, he has this statement called personal computers in 1975, the internet in 1993, and I believe Bitcoin in 2014. And Nicholas Nassim Taleb, I don't know if you have heard of him. He has a book called The Black Swan, or another book called Fooled by Randomness. He became really popular as a person who sort of predicted the instabilities that could lead to a financial crisis in 2008 and made money of it. And he has the statement, Bitcoin is the beginning of something great, a currency without government, something necessary and imperative. On the other side of the coin, you have the critics of this technology. And if you want to look up some of the criticisms, I encourage you to go to Financial Times, which is a newspaper based out of London. And this is just one of their articles. And yeah, they are telling you to beware of people like me who like to discuss Bitcoin, come and give talks about Bitcoin. They basically say that we are trying to sell you tulips of the 21st century. If you have, I'm not sure if you have heard of the tulip bubble that happened in 1637 in the Netherlands, where the prices of tulips went to the equivalent, say, of $1 million per tulip. And it all came crashing down and a lot of people were hurt. And they would say that Bitcoin is the next tulip. It's a tulip of the 21st century. I'm here to kind of give an alternative viewpoint to this. So for my talk over the next hour, these are my objectives. So I'm here to present the technologist's perspective on cryptocurrency. I'm not here as an anarchist. I'm not here as a politician. I'm here as a technologist, and why technology people, hardcore engineering people like me, are interested in the Bitcoin and similar systems. In order to go into what the crypto economy is, we must first understand what cryptocurrency is. And I want to go from basics. What is a cryptocurrency fundamentally? What is Bitcoin? What are you owning when you own a Bitcoin? That kind of question. An explanation of how these systems work, very roughly, not a complicated one, not one that goes into the details. Outline specialities of cryptocurrency. What's special about this kind of money over francs and dollars that we use every day? Illustrate the power of this technology through a couple of different applications. My talk will be broad rather than deep. Crypto economy is conceptually very big. It's a new field of engineering that has emerged in the past 6 years. And it's extremely huge in the scope of ideas that people are dealing with in this area. And my kind of attempt has to be to go and showcase you various different aspects of the technology and be shallow in each of these aspects, but to give you a broad picture. I'm not going to be deep in any of these particular topics. If you do ask me questions, we can go in depth, but it's not the objective of my presentation to be go in depth, but rather to be broad and show you like a panorama of this area of technology. And finally, I've already said it, this talk is really about the crypto economy, which is not just Bitcoin, but there are many cryptocurrencies and many kinds of things that are possible just beyond Bitcoin as well. So just keep that in mind. We'll talk about Bitcoin, but Bitcoin is just one part of what I find interesting. Now, what I'm going to do over the next 1 hour is a bit challenging for me. Why is it challenging? Now imagine the year is 1896. And as somebody who is interested in mechanical engineering, I am delivering a talk, and I know that there's this person who is Rudolf Diesel, who has invented what is the diesel engine. I know his invention. I know it is fundamentally a powerful idea that if you have a way of converting a chemical into work, it is a powerful idea. But yet, as of today, you don't have really a car that I can show to you. So I come to you and I know there's the engine that has been invented, but somebody really hasn't built a chassis around the engine, and that needs to wait for 1901 for that kind of chassis to come along. Certainly, there hasn't been the Model T. That needs 10 more years, 1908, to come, like cheap manufactured cars. They're still 10 years away. And certainly, if even I could convince you that there will be something called a car. I might find it really hard to convince that we are going to build roads for us to drive all over the country, and then we are going to build like millions of petrol stations to fuel all these cars. These kinds of things haven't happened yet. But what I can see from my perspective, or what somebody like me could have seen from that perspective, is that the fundamental idea that you can take chemical energy and you can convert it into work by which can move things is going to be fundamentally important. That's the kind of situation I am in today. I'm going to describe what Bitcoin is, and I'm going to tell you why it's important. But the technology, the Model T and the petrol stations that are needed for this technology to be used by everyone haven't been built yet. This is part of the challenge of explaining why this is an important technology to people. The challenge is this. At multiple points, I will need to appeal to your imagination rather than to a concrete service or product. Because most of these things that are possible with this technology haven't been built yet. And it's the possibilities that are huge. It is the possibilities that are exciting. Finally, as a word of caution, I'm not a lawyer or financial advisor. None of this talk should be construed as financial advice. I own Bitcoin, and I think it can be an interesting investment, but I'm not a financial advisor, so do not take this as advice in any way. And finally, we will break for around 2 or 3 sessions for just for questions. You can stop me and interrupt me at any time. And that's kind of the background of the talk. Do you have any questions? Yeah.
Well, I'm not sure if we are asking or if you're answering questions regarding the financial legitimacy of people.
So personally, I mean, I won't say how much, but let's say that I keep more than 10% of my savings in cryptocurrencies, not just Bitcoin. That's the kind of thing I do. Certainly, if I can send them to Inca, if you can circulate them, I'll Okay, so I'll go on to the next section. Next section deals with what is a cryptocurrency. What the hell is a Bitcoin? So first, we start with a couple of different observations about the financial system as it currently stands. And the kind of thinking that I want you to do over the next 1 hour, and maybe it's a bit different, is the financial system can be imagined as a set of databases, rules for making changes to these databases when certain events happen, and IT systems to facilitate the transfer and exchange of database entries from one holder to another. We will go into why I'm making this statement. And the second important point is money. It used to be exchangeable for commodities such as gold, but this idea collapsed at the end of the Bretton Woods era. So maybe 100 years ago, you could have taken your 100-franc note, gone to a bank, and actually got gold in exchange for it. And your note actually represented a piece of gold or a piece of silver. But in the 1970s, there was a system called the Bretton Woods system that collapsed. And this link between a physical commodity, gold, and the notes that we treat as money, they broke down. And so what essentially we have today is when I pay with my credit card for a cup of coffee, I'm actually getting a real good, which is coffee, in exchange for a changed database entry in some bank. Now, this, I'm not sure if it's clear or not, but I'll take 2 more slides on this, and then we can have questions on this. So essentially what is happening in the current financial system is you can imagine them as a set of databases. So a bank is essentially a database. It's a giant database and an organization to maintain that database. So you might imagine that if this is the UBS database, then they have a list of balances. So they have account numbers, the bank account numbers on the left, and then the value, the currency, and the account holder reference number. And your KYC information could be linked to here. So if this is my account number, then this might lead to my KYC information, who I am, what do I do, etc. So you have this kind of database. I want you to imagine this kind of database. And then you have, that is a list of balances, like who owns how much. And then you have also a list of transfers. Who transferred how much to whom, when. That kind of database, right? So for example, like simple transfer, it might be in batches, like transfers might occur in batches, like in many systems they do. So there might be a batch number. They might be like from which bank account number, to which bank account number, how much, what currency, and then maybe a statement that expresses that in plain English language. And if you look at these two Excel sheets, which is, I call this the balance, like a list of balances, so because these are balances, and then a list of transfers, who transferred to whom. So a bank is essentially maintaining this kind of database for firms and individuals. So if you are all at UBS, we have a database where this maybe represents one of you. And the other thing is, just the way UBS maintains this database for firms and individuals, central banks maintain these databases for other banks in the nation. So if you have, say, UBS, Credit Suisse, and you have other banks, and then there's the Swiss Central Bank. The Swiss Central Bank has a database pretty similar to this one, in which each of these accounts are basically the accounts of the banks. So you can imagine this as a set, as a tiered set, like as database at 2 levels. One is the banking level. So the bottom level is like people and companies. Then you have banks that maintain the database of these people and companies. And there are many of them. And there's a central bank that has a giant single database to maintain the balances of these banks instead. Now, on the database of the central bank has the unrestricted power to create money, which means if you have a database like this for the central bank, and basically if this is the account number of the central bank itself on its own database, then it can change the entry on this corresponding to its account and create infinite and increase this entry as much as they want to. You can quite simply think of it like this. So normally when you transfer, you are subtracting from one entry and adding to another one. So for example, when this person transfers to this person 50 francs, there's a subtraction of 50 from here and addition of 50 from here. And when money is created, nobody's account is subtracted, but somebody's account is added. And basically the central bank has the power on its own database to add as many units of money as it chooses for its monetary policy. And then the interesting thing is, if you imagine the globe, you imagine a globe, a physical globe in front of you, each nation has this database. So the Swiss have their own banks, their own central bank, that's a system of databases. I come from India, we have our own banks, they have their databases, and then there's a central bank that has its own database. So if you imagine like 200 nations in the world, there might be, I don't know, 150 of these systems, disparate systems around the world. And then the challenge becomes, if I have some money on one database, so I have 5,000 francs on the UBS database, and then I want to transfer it to my family in India, which is SBI, a different bank, then there's the challenge of changing database entries in many of these databases so that this transfer happens. And so you have systems like Target2, SEPA, NEFT, Fedwire, ACH, and SWIFT, which are IT systems that enable all of these databases to coordinate so that money flows around the world. What I want to impress upon you is because ultimately these are just databases and money cannot be changed for gold or for silver. What we are using today are virtual currencies. So there are many times when I go to people and they say, oh, Bitcoin is a virtual currency. And I tell them, no, Bitcoin is a virtual currency, but what you are using day to day is also a virtual currency. This is actually something that is a paradigmatic shift if you think about it. And one of the examples in my personal life that I came to understand this paradigmatic shift is a few years ago. My father was in the government in India, and basically like an American visited the place where he was in the government of, and then this person wanted to visit one of the very backward tribal areas in the state. And when my father took him to one of the tribal areas, the tribals look something like this. They have this very colorful headgear that they wear. And their lives are basically, their livelihood is they have cows and they are herders. So they basically extract milk and they sell milk, and this is their livelihood. So there was a situation where there was a person like this, my father, who was the translator, and this American, and my father was trying to coordinate a conversation between the American and this person who herds cows for daily living. At one point, this person asked a very interesting question. He essentially asked, how many cows does this other person have? How many cows does this American have? And my father was confused, like, what does he mean? And then my father realized what he really wants to ask is, how rich is this other person I'm talking to? What is his wealth? And then my father realized that in order to answer that question, how rich the other person is, you got to actually explain to this person that money is no longer a cow. For him, money is a cow, that's money, or money is a pig. But for us, money is actually a database entry. That's a huge paradigmatic shift that we have done over the past hundreds of years. And before you explain this kind of shift to him, you can't explain how rich somebody else is in this other paradigm. So with that, I would like to stop, and I would like to take questions. Are you really comfortable with this idea that it's finally just databases, that we are dealing in virtual currency? If there are any questions or any doubts you have about this idea, we can talk about it. But because this is an important principle, if this doesn't make sense, Bitcoin will never make sense. Mm-hmm. I think I mean, it's for me, it's kind of hard to say. I mean, at one time when you had like commodity money, like maybe cow as a money or fish as money or cigarettes as money in certain prisons around the world, you were using money, something that had obvious utility, like you could smoke it, you could eat it, or you could kill it and eat it, or whatever. It had obvious utility. From that kind of monetary system, we have come to a monetary system where it's a database entry. We can't eat it, we can't smoke it, we can't do anything with it, but it's useful to us as long as all of us accept that it's money. So it's like a social delusion. Money is valuable to me. The francs that I hold in my bank account are valuable to me because you agree to take that database entry and give me something real in exchange for it, something that I have utility in exchange for it. And it's like a social contract, like all of us believe in this, and so the system works. Yeah. I didn't get your question. So the question was, do I see any threats for currency? So, so the question was, if are there any threats to currency, and what happens if the databases end up crashing? So right now, I'm not talking about Bitcoin at all. I'm talking about normal money like CHF, USD. And the way the databases are maintained, they have good backups of it. So it's hard to imagine that the databases will end up crashing, or the backups will all end up crashing one certain day. If it does happen, then yes, we might have a challenge to the system. But I think our ID systems are good enough that it's a remote possibility. Yeah. No, I'm saying all currencies are virtual. So the cow, so the separation I'm doing is, a cow is something that is that has commodity utility value that I can accept as money, and then I can use it as a commodity, right? I can derive something physical out of it. Whereas money is something that I can take, but the thing itself, the database entry itself, does not give me commodity utility value. It's not like gold. It's like gold. I accept gold from you and give you a coffee. I can use that gold to make an ornament, right? Yeah. So what you're virtuality. So if so I can accept that. I accept that as an argument. If you believe that even cows are virtual money, great. Then my job is easier. So what I want to say is, let's not be under the this. So the difficulty in understanding Bitcoin is people tend to think Bitcoin is a virtual currency, and these notes that I have in my pocket are real currencies. So I just want to make that it clear that we are all dealing in virtual money. If you think even a cow is virtual money, we can debate about it, and that's fine with me. Yeah. Yeah. Yeah, so I think that's a good question. And the question is you're asking is what is special about cryptocurrency, right? And that's a whole section I'm going to come to. I have not talked about Bitcoin yet, and I'm going to go into your question, and there's a whole section dedicated to it. Okay, so I think we are clear on this. We're clear on this point. Now, if we are clear here, and if you're clear that it's databases, each nation having a set, and there are many of these sets around the world, then actually Bitcoin is the simplest idea on earth. Bitcoin is simple. If essentially money today is a database entry, could the database be maintained by a network of computers that are distributed all across the globe? So you can imagine that the bank, the server of the bank, or the set of servers of the bank are just, you can imagine as one computer. The central bank similar. But what if you had a network of these computers spread around the globe, and these computers work together to maintain a database exactly like the banking database, and that database records how much of a currency which account has? That's the question behind Bitcoin. It's this must be the question the inventor must have asked. Something like this, like, if you, instead of a bank maintaining the database, can a network of computers distributed across the world maintain that database? Simple, very simple at its core. If I actually go into the technology behind Bitcoin, you'll find that it is shockingly similar to the banking system. In Bitcoin, you have basically two databases that are linked to each other, that can be derived from each other really. And one is what I call the Bitcoin balance list. This is not the official name for it, but this is my name for it. And in the balance list, you essentially have what are called Bitcoin addresses, which are these long strings. And then how many Bitcoins does one account hold, a particular account holds. So for example, this account, it holds 73 Bitcoins today. It's a very rich person. And this is exactly similar to the balance sheet I showed, balance list I showed before, but Bitcoin has this balance list. And then there's the Bitcoin transfer list. The transfer list is essentially, for example, let's take this line. So if this is my account and I want to give Inka some money, and Inka has this Bitcoin account number, Bitcoin address, then the transfer list is just a statement that says, from my account to Inka's account, transfer 62 Bitcoins. And then what I have is every account number, every Bitcoin address has a password that only I know of. So when I want to do this transfer, I basically have to take my password, take this statement, and then there's a mathematical calculation that my smartphone needs to do, and it creates the signature that basically proves that this statement was generated by a person who had the password to this account number. So this signature is proof that this statement comes from somebody who actually owns the password to the account. And basically, if you have transfers happening all around the world, so me transferring to Inka, like some Thomas transferring to Urs, then all of these transactions are collected by the network, and then they are organized into what are called blocks. So this is a block. So that's a block number. So I think it's 100,002. Then there's the next block, which has this next set of transactions, 100,003. So similar how, like the way we have in the SEPA system batches, we have in the Bitcoin system blocks, and the Bitcoin ledger is basically these set of blocks that have transactions. and these blocks follow each other in a chain. That's why it's called a blockchain, and that's why this technology is called blockchain technology. But it's the idea of it is perhaps at least 100 years old, the idea of taking transactions, batching them into blocks, and then chaining them. So it's pretty simple if you think about it. And so Bitcoin essentially is the combination of these two databases, a balance list and a transfer list. So when a transfer is entered, it changes the balances, obviously. Like if I transfer to Urs, my account needs to be subtracted, his needs to be added. So there needs to be changes made in these for each transfer. Now the way Bitcoin works is we got into this idea that Bitcoin is basically a database. Okay, yes, let's. Yeah. Yeah. So first of all, we do not want to convert every currency into Bitcoin. Bitcoin is just a system we run. We love how beautiful it is, and we love some of the special features it brings. I'm going to get into them. And we are happy to just run the system. I mean, we are not trying to make this a benchmark or make this XYZ or ABC. We are just happy the way Bitcoin is, and we just want to run it as a currency. But the idea is we are going to take a network of computers, have them manage a database. That database will have this kind of balance list, and the values corresponding to each account represents how many Bitcoins a particular account has. That's it. Just like UBS, like if you think about the central bank, the database of the central bank is essentially something like this. It's like some central bankers came together and said, we think it's a great idea to maintain a database for the people of Switzerland, and then whatever the numbers we write according to their account numbers is the number of francs they have. They came and said that it's a group of enthusiasts like us that came together and said, yeah, we want to come together, have our pool our computational resources together, and run a network. And that network basically maintains a database, just like the banking databases. And then you have addresses, and then you have amount, and what that amount represents is Bitcoins. It's a virtual currency. We don't want to make it a benchmark or something. If you want to use gold, please go ahead. Frank, I mean, there's no question of making it a benchmark. Just find it's an interesting technological experiment. Yeah. Yeah. How they come. So this is my next slide. This is a very important question. How are Bitcoins created? So normal francs, they are created by the central bank, or to be precise, they are created by the central bank and the normal banks. They can create francs, but the normal banks, their power is a bit limited. Central bank has infinite power. So to a first approximation, we can think Swiss francs are created by the central bank. That's how new money is created. How a new Bitcoin is created is the question. That's a brilliant question. That's my next slide. Other questions? Yeah. Yes, that's a brilliant question. So so in the normal bank, so what the question is this. In the normal bank, we always had this account holder reference number, and that was linked to the identity of the person who was holding the francs or the US dollars. In Bitcoin, we don't have a reference number. So for all we know, this account could be anybody in the world, and Bitcoin breaks the linkage between the identity of the person and his Bitcoin address. Now, By default, Bitcoin breaks this linkage, but if you use Bitcoins, you might reveal them accidentally. For example, let's say I am the owner of this address, and that has 86 Bitcoins. If I make a transfer to Inca, who has this address, then Inca knows that the transfer came from me, and that transfer and the address, the originating address was this one, so most probably Meher owns this address. So you can figure out who owns which address depending on the transactions that happen, but by default, the system does not have any link between the Bitcoin address and the real world identity of the person that owns the address. Yeah. So this, I think this is one of the important questions, and let's go into it after the presentation. The question is the separation of real world identity from the Bitcoin network, is it a good thing or is it a bad thing? Something like this. I don't want to frame it in terms of good and bad, but the question is something like that. And it repeats, the same question repeats across many instances. Your Greek example is one, people take other examples. Some people say, what if somebody donated to the ISIS through Bitcoin? Wouldn't that matter? So we'll go into this, yeah. Yes, yes, that would be possible. Exactly, that is exactly possible. So let's assume that, like, this is the central bank, Greek central bank's account, and this is the hacker's account. They make this transfer here. Now when this account transfers to somebody else, that transfer also enters the blockchain. All of the transactions enter into the blockchain. And if the hackers, they are not careful and they transfer money to somebody and the law authorities know that somebody's address, then they could trace it back to the hackers. So forensics, financial forensics is possible with Bitcoin. There are brilliant softwares that are coming up to do financial forensics with Bitcoin. So it's definitely something that's in the works. Another question, yeah? That's another interesting part. You can create infinite addresses. So I won't go into how that works, but basically you can take your computer or you can take a piece of paper, and if you know a certain calculation, you can create infinite addresses. The addresses are not restricted in any way. Okay, so I think we are clear at this stage. So essentially what happens is that there's this big network of computers, and each of these network basically holds a copy of these databases. Each computer, and I run one of these computers, there are 10,000 of them today, and each of these computer holds a copy of this database. And when somebody makes a transfer, like, I don't know, Alice transfers to Bob, she basically creates a state, do this transfer, and then this statement is sent to all of these computers around the world, and this takes around 2 seconds today. So if I'm transferring to Inca, I make a statement. Our IT systems are so good that perhaps in like 500 milliseconds, most of these computers will know that I want to transfer to Inca. That's so good that we are in this day and age. No. Yes. Yes. So yeah, this is exactly right. High frequency trading with Bitcoin is difficult, but people are building systems to circumvent this. Like they're not Bitcoin, but they're building something on top of Bitcoin that can offer faster service. So, but the core Bitcoin system itself is quite slow by comparison. So the question, money creation is in Bitcoin. Where do Bitcoins come from? It's a very nice question. So in the previous one, we saw basically you had a list of balances, but like how did we get to this list? From where did it come? So, so basically these computers that are maintaining the Bitcoin network, there are of two types. There are auditors and there are miners. So auditors are easy to understand. What an auditor does is it takes these databases and then makes sure that the balances on them are correct, like the mathematics adds up. This is what I run in my home, like an auditor of the Bitcoin network. Take the whole balance sheet, the sheet, make sure all the accounting is correct. That's the auditor, easy. There's the other type of computer that's called a miner. The miner is very interesting. What the miner does is, it actually builds the blockchain. So you have this block, then block number 100,004 must come. Some miners, the mining computers in the world are trying to build the next block, in a sense. So miners are the one that build the ledger, auditors are the one that audit the ledger. It's a separation of duties. Now, what happens is, the Bitcoin software is designed in a way that if you are a miner and you help build the ledger, then the network pays you Bitcoins. And how does the network pay you Bitcoins? It pays you Bitcoins by the creation of new money. So let's get into that concept. So if you see this block, you'll see that this line is a bit strange. It's different from other lines. So this particular line may be me transferring to Inca, but then this line, it does not have a from address. It only has a to address, and it doesn't have a signature. So there must be a miner in the world that created this block, and that this miner added it to the list, to the blockchain, because there are blocks previously. So this block starts from 0 to 100,001. This is 100,002. So there must be one miner in the world that actually created this block. And the miner who created this block has a special power. On his own block, he can put his own address and basically say, tell to the network, add 25 to my address, but do not subtract anything from anyone's address. Just the way central banks can add to their own address and not subtract from anyone's address, the miner who is creating this block can add to his address, but not subtract from anyone else's address. And this is how new Bitcoins are created. That is money creation in Bitcoin. Now, what the Bitcoin algorithm does is, it basically, the software says how many the miner has a power to create. So right now, the miner can create 25 for each new block. And in Bitcoin, the way the system works is a block comes in every 10 minutes. So every 10 minutes, a new block is created. So the algorithm specifies that right now, every 10 minutes, we will have a block, and 25 new Bitcoins can be created by the miner that created the block. So this is how new Bitcoins are created. So when I have some Bitcoin, those Bitcoins were created by some miner in the world when he created one of the blocks in the past. And then once the miner has the money, the newly created money, he can spend it like normal Bitcoins. So what this system is doing is pretty interesting. It is giving an incentive for people to maintain the network. You become a miner because by becoming a miner, you can earn new Bitcoins, And what you do as a miner helps maintain the network. So it's almost as if this is a science of economics which is called game theory. I am not sure if you've heard of it, but it's basically you have many different agents around the world, many different people around the world, and by giving everyone some incentive to do something, they're all collaborating together to build something big, which is the Bitcoin system. Yeah. So this is many people say this is one of the flaws of the Bitcoin system. There is no incentive to be an auditor. So this is not exactly right. For example, what is my incentive to be an auditor? My incentive is I love Bitcoin. I love the idea of Bitcoin. I would love to build an auditor so that the system stays honest. For some people, if you are an auditor, you get transactions faster. Like you receive information about the Bitcoin network earlier than somebody who is not an auditor. So maybe that informational advantage is valuable to somebody. But there is no incentive per se in the protocol itself to reward these auditors. Yeah. So basically, the auditors, if there's a block that the auditors don't agree with, then they will flag the block as not valid. And once a lot of auditors flag the block as not valid, the users don't get to see that block anymore. It's in the system, but like if I'm a user, I can basically ask a couple of auditors, do you think that this block is okay? And they'll say no. So I won't use that block to make my financial calculations. So they are kind of a filter. Yes, go ahead. Yes. Brilliant question. So the answer is, so the question is for the recording, how many entries can you have maximum in one block? So if you have this block, as of today, you can have around, so every block comes in every 10 minutes. So every 10 minutes there's a new block. In one block, today you can have you can have 4,200 entries in a block today. That's the rate today. And this is one of the engineering challenges with Bitcoin. How do you take that number from 4,200 entries in a block to 42,000? Because if Bitcoin is to compete with Visa, just using this system, not using anything else built on top of it, then basically this needs to be something like, this needs to be around 420,000 or 500,000 entries in one block if you want to compete with Visa on a global scale. Today you can only do 1% of it, that's 4,200. It's an engineering challenge. How do you go from that 4,200 to the Visa scale? It's something like the challenge that the internet faced when in the 90s, internet you had like 32 kbps connections, and today you have, I don't know, 32 Mbps connections. That sort of challenge exists with Bitcoin. Yeah, go ahead. Yeah. So no, the blocks, the protocol, the network is designed so that the blocks come in every 10 minutes. What you're referring to is a bit different. The problem is the miners, they are actually competing to build the next block. Because with every block, they actually need to make a every block has a puzzle. There's a puzzle to every block, like an equation that the miners need to solve. And all the miners in the world are trying to solve this equation If they find a solution to this equation, then they can create the next block. So that's how, if there are like 1,000 miners and they're all trying to create a block, and let's say new miners join in, from 1,000 it becomes 2,000. So there are many more people trying to solve the equation. So maybe the chance is that the solution is attained faster. Instead of 10 minutes, they find it in 5 minutes. But then what happens is the network adjusts, it takes the equation, and for the next block, it makes the equation even harder. So that blocks still come in at every 10 minutes. So the more miners join in, the kind of problem that the miners have to solve become harder. And so the blocks come in every 10 minutes. It's like this, like let's say all of us were given a very hard mathematical problem to solve together by the professor. Normally he knows that in 10 minutes, if we all work together, we can solve it in 10 minutes and create the next block. But now let's say the class size doubles and there are, instead of 50 people, 100 people. Then the professor thinks, okay, maybe with 100 people, instead of solving in 10 minutes, these guys are going to solve the problem in 5 minutes. So then the professor, which in this case is the protocol, basically makes the problem harder. And by making it harder, the solution still comes in every 10 minutes. So every 10 minutes, one block is created. Somebody there had a question, yeah. We will get into this. This is the next section. We will get into this. Please go ahead. Around 10,000 today. Anyone can be an auditor. You can go and today download a software on your laptop, make it an auditor. So if millions of people want to become auditors, they're all welcome. Yes. So basically anyone can become an auditor. Like we're going to go into this. This is another slide. It's an open system. Anyone can become a miner. Anyone can become an auditor. There is no restriction. Please go ahead. Yeah. So the miner doesn't get paid, and the transactions will be included in another block by another miner. So the user will still have his transactions go through. Please go ahead. Yeah, the auditors don't get paid. That's an interesting thing. The auditors don't get paid. People debate whether that's a problem or not. I don't think it is, because like there are people like me who run an auditor just to make sure Bitcoin is working well. And I think there'll always be people like me. Yeah, please go ahead. Yeah. So generally the exchanges, they need very quick information about the network. And so they become an auditor so that they receive very quick information. Yeah. Yes, yes. So in general, the idea is if you're building a service on Bitcoin, let's say I'm building a remittance service on Bitcoin, right? Like where, if you want to send money to India, you come to me and like, I transfer money through the Bitcoin network. For people like me who want to build services on Bitcoin, it makes sense to be an auditor for multiple reasons. A, you want the system to work well because your livelihood depends on the system working well. So you want to be an auditor. And B, if you're an auditor, you get information about the system earlier. So you send a transaction and the auditor hears about the transaction first. So that's some incentive to run nodes. People like me in the real world, we run it out of just fun. So to be honest, I don't know how it worked. Yeah, I'm not sure how it was designed. It's not something I've thought a lot about. maybe opportunities like that exist, but it's also the case that anyone can become an auditor. It's not. No, there's no competition between auditors. It's like you just run an auditor, it verifies that the accounting is correct. Then people might ask you, has my transfer happened? And you reply to them, yes, your transfer has happened, here's the proof. So with the auditors, it's not an element of competition. With the miners, there's an element of competition. To build the next block, yes. Yeah, so I understand your question and I can answer it, but perhaps we should take this offline. No, not because it's complex, because that would essentially need me to get into the mechanics of what the calculation is. So I don't think it's worth it. But we can discuss it offline. There's the answers to it. Yeah, go ahead. Exactly. So this is an important point in Bitcoin. I send the transaction, all the auditors and miners hear about it in 500 milliseconds, but the next block might be made 10 minutes later, and so we actually need to wait 10 minutes for our transaction to be included in this ledger. Yeah, go ahead. Yes, so that's my next slide. Yeah, go ahead. Yeah, so basically that's what the auditors and miners are for. They will reject some of your transactions and accept only those transactions up to 20 Bitcoins. The rest will be rejected. Yes, that's the job of the auditor, that the accounting is coherent. Oh, there's another one. Yeah, so this is the question of inflation. We'll get to it. Okay. So, inflation, deflation, and many questions on that. So, so today, if you mine a block, you get 25 Bitcoins. When the creator of Bitcoin created the system, he created a schedule, which is this. A very famous curve in our community. So what he did was, so today you make 25, but when the network started, the miners could earn actually 50 Bitcoins for creating a block. And in 2017, they will earn only 12.5 Bitcoins. In 2022, they will earn 6.25 Bitcoins for creating a block. The reward for the miners keeps shrinking with time. Because the reward keeps shrinking, the inflation keeps falling. And ultimately, the inflation goes to zero. As time progresses, new and new Bitcoins are created. So the number of Bitcoins keep rising. But ultimately, somewhere around 2040, the number of Bitcoins will attain a peak of value of 21 million Bitcoins. And that's it. That's it, no more. So today we are somewhere around here, which is around 60% of all Bitcoins in existence. Like 60% of 21 million, like 14 million or something like that, have been created. But we'll go until 21 million, and that's it. Inflation meaning, inflation here has a different meaning than consumer inflation. Inflation is if this year we had 100,000 Bitcoins in the beginning, January 1, we had say 10 million Bitcoins, and December 31, we had 11 million Bitcoins, then the inflation is basically 11 minus 10 divided by 10 into 100. Inflation meaning the percentage increase of the money supply over the previous year. It is not linked to a consumer basket. Yes, 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 yes. Yeah. To create. Okay. So now here comes an interesting point. Like he's exactly right that if you have Bitcoin inflation, which is defined a bit differently from consumer inflation, if it goes to 0, why would the miners create blocks here? Now there are two things to it. The first is, over time the value of Bitcoins is also rising, and it's rising because there are more users to the system. When I started with Bitcoin 2011, 2012, it was $3 a coin. Today it's $380 a coin. So there's price growth because there are new users. So even though the block reward has reduced from 50 to 25, if you actually count it in dollars, it has increased over the last few years. So if Bitcoin becomes more valuable, even though the block reward keeps shrinking, in dollars it's still a valuable amount. The second thing I omitted for simplicity was, whenever a transaction happens, so I am sending to Inca, I actually need to give some transaction fee. I need to say, okay, for transferring these 62 Bitcoins, I give 5 cents to the miners. And the miner who creates this block not only gets this reward, but also the transaction fees from each of these transactions. So when this actually goes down to 0, transaction fees are how miners will have an incentive to still keep creating new blocks. Yeah, go ahead. Yeah. Yeah. So we want to have a free market. So the way it works is, right now you can have 40 to 100 entries on a block, and every transaction specifies that we are going to give XYZ fee. Like somebody says, I'm going to give 10 cents fee, somebody else says, I'm going to give 5 cents fee. And then the miner has a free market, that these are all people who want to do transfers. Here's what they are agreeing to pay. And he can select which ones give a good enough fee, put them in the block. So there's a free market to decide which transaction goes in. Yeah. So, can you repeat your question differently? So, like how much, like, is there a few miners that seem to get all of the business, or is it very diverse? Like, how much money do these ones that get a lot of it actually get? Yeah, it's so. So to be honest, like there are people who study this aspect of the network. This is an aspect of the network that has not interested me. It's an interesting question. I suspect it's like other things in life. There are like big producers of acetone and small producers of acetone in the world. So there are big miners and there are small miners, but I don't know what's the distribution of the reward among them. I haven't thought about it too much. Yeah. Go ahead. Yeah. 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 So there's inequality of two types. Inequality of two types. One is between the miners and one between the holders. So yeah, so basically like the algorithm adjusts so that a block is created every 10 minutes. And by counting the number of blocks that came, it can actually measure time. I don't understand the question well. We could discuss this, but roughly the thing is, it's network adjusts in a way that blocks come every 10 minutes, and that is how the time is measured. But I think that doesn't satisfy you. We can take it offline for sure. Yeah.
And I see that we have 15 minutes left.
Oh, okay. Okay, then let's go to the interesting parts then.
I'm the auditor here.
Yeah, no. So simple. It's digital gold. There are only 21 million of it. Even though I'm a Bitcoin enthusiast, when I have a chance of spending Bitcoin, francs, or rupees, guess which one I pick? I pick the currency with the most inflation, which is this one, 10% a year. And I'm a Bitcoin enthusiast. I don't end up spending my Bitcoins because I want to hold on to them. Now, specialities. Now, let's go into some non-obvious things about Bitcoin that are important, in my opinion, for the last 15 minutes. The first is Bitcoin is open source software, which means you can go to this particular site, github.com/Bitcoin, and you can see the whole code that miners run, auditors run, the whole network protocol, how the money will be created, everything. Everything is open source, auditable. There's no secrecy here. And this is actually what gives Bitcoin its security, that anyone who is a computer programmer can go and look at the code and see if it doesn't work or try to break it. You can go to Bitcoin Talk forum, and Bitcoin Talk forum is probably the greatest encyclopedia of cryptography I know of. People over 6 years posting ideas on the technicalities of Bitcoin, new kinds of cryptography, etc. It's huge. There's no way a person could read it in his lifetime. And everything about the Bitcoin protocol is discussed open. There's no secrecy completely. And this is actually different from the conventional banking system. Generally, banking systems are closed source, which means you don't know what code UBS is running. Or let's say only a very few programmers that are employed by UBS actually know the code. Bitcoin, by being open, is like it's inviting any hacker to come, find a bug in the protocol, and either profit from it if he can, or if he can't, or if he's good, then submit to the whole community that this is what is wrong with it, and please improve this. So Bitcoin keeps improving at a very fast pace because it's open. And this might seem like a minor thing, but actually if you go into the history of attacks on banking systems, there are quite a few of them. And I suspect that even if, as many people think, Bitcoin may end up failing, I think many banks are actually going to take the Bitcoin software and actually use it to build their own systems. Just because the Bitcoin software has been audited by so many programmers, hackers, security researchers around the world. This is a major strength. Not to mention that I actually feel safer using the Bitcoin system because I see the system that's open, and I somehow trust that it's much more safer as an IT system as a whole. Then inclusiveness and censorship resistance. Anyone can convert the computer in auditor. Anyone can become a miner. Anyone can create wallets, which are access points to the network. You want to create transactions. Anyone can build those. Anyone can develop point of sale systems for use with Bitcoin. And the system ensures security for users, miners, auditors, everyone, not through lawyers and policemen, but through intelligent design arising out of game theory. That's Bitcoin. Then the other thing is, it's censorship resistant, which means if I make a transaction today on the Bitcoin network and I send it to the network, there's no political entity around the world that can censor my transaction, say, no, you can't do this transaction. And Bitcoin is an open automated system that way, that whoever sends a transaction, it will accept, no questions asked. And you might think that's a very minor thing. It's actually not. If you think about it, in the Greek crisis, what happened? Suppose you were a Greek citizen who accumulated, worked 20 years, accumulated 200,000 euros in savings. Suddenly the Greek government comes to you and says, look, we screwed up. We didn't manage our finances well, but now the only way we can pay off the European creditors is by restricting you from your own money. You can only take out 60 francs of your money per day from an ATM machine. The rest of the 200,000 you cannot touch. The government is censoring the person's transaction. So the Greek, he wants to transact 500 euros. The government is censoring that and saying you can only do 60. Philosophically, politically, we believe that no power on earth should have the power to censor financial transactions. And this should not be allowed to happen. And Bitcoin is exactly that system. It's censorship resistant in all ways. Mobility and broad reach. So cryptocurrency like Bitcoin plus some other systems built on top of it. This is not pure Bitcoin, but there's something additional into it. What they could enable is international payments in under a second, point A to point B on earth, no questions asked, under a second, your money goes. Flat transaction fees, potentially going as low as microcents per transaction. So maybe your transaction fee might be 10 microcents for a transaction. What that enables is a microtransaction. Like you can send one rapin through Bitcoin to India today in 1 second. That does not happen in the normal system. Anyone with a smartphone in any jurisdiction can be part of a global financial system. So the thing is, many places in the world don't have a good financial system, but they are starting to get smartphone technology. You'd be surprised that in India, people who you would think as very poor actually are starting to get smartphones. And by 2020, it said that 80% of the Indian population is going to get smartphones. They are all customers of Bitcoin. The Indian financial system is very poor. In Switzerland, we are blessed with a really good one. So we don't realize that there are other places in the world that don't have a really good financial system. With Bitcoin, somebody builds an application in the United States, an Indian can use it with his smartphone. That's a huge population. That's the empowerment Bitcoin can do. And that opens the door to applications such as a microtransaction-based web. So on YouTube, instead of seeing a video, you pay like microcents per second of video that you see. That kind of web economy is possible. Machine-to-machine transactions for resource allocation. Like we normally tend to think like it's humans sending money to humans. With Bitcoin, you could have systems where machines send money to machines to do something. My machine wants to take this piece of data from your machine, so it sends you some money and gets that data. Machines can trade very quickly in very low amounts. Finally, this is very important and very hard, and I don't have enough time for it. But Bitcoin, not Bitcoin, but the next generation of Bitcoin, which is Ethereum, it's another currency called Ether, very similar principles to what we discussed. It's actually programmable money. It implements the concept of programmable money. So in normal money systems, we assume money gets transferred from a person to person or a person to company. With cryptocurrency, you can have people transferring money to programs, programs having their logic and memory of their own, and under certain condition, programs transferring money to other people or companies. So imagine the simplest example, maybe it's not even practical, is this one. So you want to buy, like Bob wants to buy shoes from Alice, and Alice wants dollars for those shoes. So Alice doesn't want to send the shoes until Bob sends the dollars. Bob doesn't want to send the dollars until he gets the shoes. It's a coordination problem between two humans. The way it's solved is there's a third party, most probably PayPal or Alibaba, in the middle that says, okay, I'll hold the money from Bob, and when Alice proves to me that she sent the shoes, I will verify her proof and send Alice the money. So it's two people across the world, they don't trust each other, and to solve the problem of trust between two people, there's this PayPal or Alibaba middleman in here. What you can do with programmable money is you can replace the PayPal or Alibaba with a smart contract, a program that has its own logic that can verify the proof of shipment from this party and hold the money on behalf of this party until it receives the proof of shipment. So you're basically replacing, so to solve the problem of trust, you have a human. Here, to solve the problem of trust, you have a computer program. So this is the description of basically a smart contract, that it's a program that can accept transactions, money from the Ethereum network or Bitcoin network in the future. It can accept information about the world, what is happening in the real world. Has Alice sent the shoes type of information? And then if certain conditions are met, then make these transfers accordingly. So you have this kind of system possible. And basically, like, programmable money makes it very easy for programmers to create new financial services, because building a financial services becomes a matter of just coding and deploying it to the Bitcoin or Ethereum network. And there are many ideas for this. There are many application ideas. Basically, what these programs can do is you have systems where there are humans and they want to coordinate to do something, for example, like build a company. And the program is basically the company. So imagine like we have a company. So company is basically a financial structure. Like, it receives money from customers, it pays out salaries, and you represent all of these rules in the form of a program. And so basically there are many humans around the world that are working, that are collaborating together, and all the finances are handled by this program. And these kinds of applications are possible. Right now, what people are focusing on is like prediction markets, predicting future events, what's going to happen, what's the probability of Hillary Clinton getting elected. Insurance, I think it's a similar thing, like you pay a program premium under certain conditions, certain disasters happen, the program verifies that it actually happened, it pays you back. That kind of insurance markets, those are possible. Escrow, this was an example of escrow. 3 minutes. Okay. Yeah, so I've run out of time. In a sense, like, programmable money is fundamentally a concept that enables new kinds of financial services. And the big advantage of this kind of system is, this is the final slide. For a small developer, for a very small developer, he has the choice of building on a conventional system and building on cryptocurrency, a financial service, What cryptocurrency allows is for him to build a service in a very convenient system at a very low cost. Why does that happen? That happens because the market for a financial service on cryptocurrency is global, whereas this is a national market. Developer convenience is very huge. This system is way better than the banking API system we have today in terms of just convenience. Regulatory burden, because it's censorship resistant, you deploy a program to the network, that's it. You don't need to ask anybody for permission. And the communication for development is completely open as well. So these kinds of things actually reduce the cost of starting financial services businesses on this economy. And this is what attracts many developers, programmers, hackers, enthusiasts to this technology. With that, I think I should end. Yeah. No, it's completely fine. I wanted to cover some futuristic examples, but we are out of time. But that's okay.
Wondered how we could show our appreciation for your presentation. Paying you in Bitcoin was technically too demanding for us.
Yeah, understandable.
And we wondered what other currencies would be available, and we came to a very traditional solution.
Perfect. Perfect.
Inca has been mining a little bit.
Thank you so much. Thank you, Professor.
I can only offer a very small thing. This is another world currency, or used to be. This is a true cowrie shell, which you can put to your savings in the very unlikely case that Bitcoin is reduced.
Thank you so much, Professor. Thank you. Thank you so much.